Uniswap is the #1 dApp on any blockchain. It has more than $1 trillion of lifetime trading value, and it does more than $100 billion every single quarter in trading volume, which is more than giant exchanges like Coinbase. But only the top 1% of blockchain developers know how it actually works under the hood. So today we're going to break it down. Let's get started. So Uniswap is an exchange, so it lets you buy and sell cryptocurrency. So for example, I want to buy ETH, and I want to buy it in USD. But the question is, how do I know how much this ETH should cost? In order to understand how we can price this asset, it's useful to understand how existing systems like Coinbase work. So Coinbase uses something called an order book model. In an order book model, there's a buy side and a sell side. So on both sides of this marketplace, people say whether they're willing to buy or sell Ether for a specific price. So someone says, hey, I'm willing to buy Ether for $100 US. Someone says, hey, I'm willing to sell it for $3,000 US. And we keep getting new prices here until we reach an equilibrium. So we might get, hey, a buyer at 1,500 and a seller for 1,500. And so now we have, this is a match. We're able to actually execute this trade, and someone can sell this asset to the buyer. But remember, Coinbase is actually controlling this entire thing. So they're managing the order book, and they're the trusted party that's actually managing this order flow. And that's Coinbase's entire business, is that they're the intermediary for this buyers and sellers. But Uniswap doesn't work this way. Uniswap is something called a decentralized exchange. So there's no central party intermediating these transactions. So how do we actually determine the asset price? Well, the cool thing about Uniswap is that you interact with a smart contract directly. And so people deposit money into the smart contract, and the price is determined algorithmically. So how does it happen? We deposit Ether and USD into the contract, and we might deposit, let's say, 1 ETH and 1,500 USD. And now the price of each asset is actually just determined by how much of the supply of each asset exists in the contract. So if you want to get the price of ETH, you just take the supply of USD divided by the supply of ETH. So that equals 1,500 over 1, which is equal to 1,500 USD, which is the price. And we can do the same thing in reverse. So we can say, hey, how much is 1 USD in ETH? And it's just going to be the amount of ETH over the amount of USD. So that's how much we're going to get for $1 US, is 1/1500th of an ETH. This concept is known as the spot price. The thing about the spot price, though, is that it represents the current reserves. It doesn't represent, if I'm making a swap, how much money I'm going to get out, which actually seems like the more relevant thing. So if I'm swapping $500 US into this pool, how much ETH am I going to get out? So now we introduce the magic formula that makes Uniswap work, which is X times Y equals K. This is very simple. It's just X represents the supply of A, Y represents the supply of token B, and K is the constant product of these two values. So using this magic formula, if you give me some of token A, I can tell you now for any token pair how much of token B you should get out. Let's say we have a pool between two stable coins like USDC and USDT. So they should both be ideally $1 USD value. And let's say the supply of both of them is 200. So 200x 200y would be K equals 40,000. So now we have this graph here. And this curve actually represents the price of each asset relative to each other. So we can see the starting point we have here, 200, 200. So this represents our spot price initially. This makes sense because both of them should be equivalent to each other. They're both stable coins. But the question we wanted to answer was, if I trade some number of USDC, how many USDT should I get out? And that's where this curve is really useful. So if I trade, let's say, 1 USDC for 1 USDT, I can look at this value here, 201, and see that I get 199.005 out of the other token. And we can continue to see on this curve, depending on how far we go, we get different values. So the further I go on the x-axis, I get lower and lower y values. So if I'm here at 300, which means I'm trading 100 USDC, I'm only getting out 133 USDT, which seems pretty weird because the value of both of these tokens is supposed to be $1 US. So why am I getting so little out when I'm doing this trade? So this concept is known as slippage. Slippage is the difference between the spot price, which is the ratio between the two reserves. So remember, it was at this point 200, 200, versus the actual execution price, which is the amount of output tokens you're getting based on how many input tokens you provided. And if we look at this curve, we can see the larger trade that we make, the larger the slippage. So if I make a really, really big trade, I'm getting less and less value out of my trade. So this might seem weird. Why do we have a system where you're not getting the expected price of the asset? If I'm trading two stable coins, I should get the same value out. But actually, since this is an automated system, remember, there's no third party. We're just interacting with the smart contract. We need a way for this to obey the laws of supply and demand. And what this curve allows us to do is that when there's larger trades happening, it means that there's a lot more demand on that side of the equation. And so the price of the corresponding asset should actually be higher relative to the other one, which has lower amount of demand. What ends up happening in practice for very liquid pairs, like let's say the x-axis is USDT and the y-axis is USDC, is two main things. We have, first of all, very small token supplies on this axis. In reality, for Uniswap, there's millions of tokens in the USDC, USDT pool because it's a very commonly traded pair. And so the benefit of that is that the delta X you get here for any individual trade is much smaller than what can really meaningfully change the price. So if this was 2 million, for example, and this was 2 million, and if I'm trading 10,000 tokens as my delta X, it's only going to move this very, very small amount. And so the effective output tokens I'm getting is still going to be very close to the spot price. But let's say I still do make a very large trade. So let's say I trade 2 million USDC here. And I'm going to actually end up only getting about 1 million USDT out of this. And so now this pool is very imbalanced. We can see there would be 4 million USDT and only 1 million USDC. The cool thing about Uniswap is that there's actually a self-correcting mechanism here. Anyone can see that there's an arbitrage opportunity here, right? So these are both supposed to be valued at $1, but we can see that there's 4 million USDT and only 1 million USDC. So the relative price is about 25 cents for an asset that's really worth $1. And so what I can do is now I can actually buy all of this excess USDT to get back to equilibrium. This will be my buy. And now we're going to get back to equilibrium. And this actually ends up happening in practice because why would I not do this? I can make a lot of money here because I know the fair market value of this asset is much more than this 25 cents of this pool. And so that's a very nice property of Uniswap, is that it's a self-correcting market where if there is a very large arbitrage opportunity due to a high slippage trade, then other buyers are going to immediately seize that up if it's actually out of the fair market value of this token. And we're going to very quickly return to the fair market value. We can model what we just saw on the graph using our same xy equals k equation so that we can get a more generalized version and we can derive any arbitrary output y or output x given the input tokens for this USDC or USDT example. And so all we're going to do is add this delta y and delta x terms to represent how much are we moving forward on the graph. With this new equation, we can do some algebra to determine how many output tokens we should get for any arbitrary input x given any x and y values. So now that we have this formula, we could plug in any values for x, y, delta x, and get the amount of tokens that we would need to output. Now we understand how Uniswap pools work. We know how you can swap between assets, how prices are set, and how the laws of supply and demand dictate this market between the two assets. But there's still one question remaining, which is how does money actually get in these pools? And that's where liquidity providers come in. Liquidity providers are the people who are actually providing the money that you can trade against in the smart contract. So in the ETH USDC example, I might add 1 ETH and 1500 USDC, and then different people can trade against this pair. The reason they do it is because every time people trade against this USDC ETH pool, there's a small fee that goes to the liquidity providers. So over time, if a lot of people are using this pool, I can make a lot of money being a liquidity provider. Liquidity providers' ownership of a pool is tracked in a very interesting way. It's kind of like a stock. So you can imagine there's a bunch of assets in this ETH USDC pool. And let's say there's 10 ETH in here and there's 15,000 USDC. So I deposited 1 ETH and 1,500 USDC. So I basically own 10% of this entire pool. And so what happens is that as people trade on this pool, my ownership is always tracked constantly with LP tokens. Regardless of the relative price of these two assets, as long as the amount of money in the pool stays the same, I always own 10%. So if the ETH price goes down relative to the USD, or the USD price goes down relative to ETH, I still get 10% of both assets when I withdraw. If more liquidity is added, then I get diluted. So if this gets doubled to 30,000 and 20 ETH, then my 10% is going to become 5%. Liquidity provider is high slippage trades. If the price of these two assets diverges a lot from what the initial value that you put in, which you thought was the fair market value, then you can actually lose money relative to just holding one of the two assets. This is called impermanent loss. So now you're a master of Uniswap. We went over the order book model, which is the old way of doing things at centralized exchanges and a decentralized exchange. We went over the spot price versus execution price and how when you make very large trades, you can get a lot of slippage. We went over XY equals K, which is the curve that's used in place of a centralized market maker called an automated market maker, which allows you to determine the price of any asset algorithmically based on the supply of the two assets in the pool. And we went over liquidity providers, who are the people that are actually providing liquidity and how they make money and what their risks of being a liquidity provider are. In the next video, I'm going to show you how you can build the DEX just like Uniswap in only one smart contract.